And if nobody has a question, I guess we'll just be reviewing. If anybody is there, do you know the page number? 57. Okay, so anybody on any of these have an issue and you want me to look at it?
Number 10.
Number 10. Okay, and keep in mind, guys, I'll probably ask the person who asked me this question, what did you do? And I'll let you know if you're on a good start, because if you got stuck and you didn't know how to match them, it's totally understandable, but you might have done a bunch right. And whatever you do, don't cross something out on your test or erase it unless you've got something better to put down, because you might be, literally, you might have done 75% of this right, and you just couldn't close the deal, and I might just dot you. Even though you couldn't get there, you might have done almost everything right and just didn't see how to finish it off. So what did you do? Did you do anything, or did you just look at it and go, I have no freaking idea?
I multiplied by 1 minus tan squared theta by its conjugate. And then,
On the top and the bottom here?
Yes.
Okay. That ended up giving you tangent to the fourth?
Yeah, and then that's where I stopped.
Yeah, so that probably wasn't a good idea, but I like that you didn't just stare at it, you tried something. Okay? So I do like that. It's always worth trying something. But if you get in a place where you're like, okay, I just made it worse, you probably want to back off, because we don't have anything with tangent to the fourth. Now, it's tempting to replace that with secant squared, isn't it? But it's not 1 plus, so I can't do that. Now, here's what I would do, first glance. When I look at the left and I look at the right, I'm talking about two entirely different kinds of trig functions. And I don't even know if tangent's related to sine and cosine. Is it? I mean, it's sine over cosine, right? So maybe the thing to do to make the right side equal to the left side, or the left side equal to the right side, is to change stuff to sines and cosines. That might be the thing to do. But man, there's something about this that looks familiar to me. Man, it looks a lot like tangent of 2 theta. If I could only just multiply both sides by a 2, but I can't do that, can I? Let me ask you this. If I can't multiply both sides by a 2, could I multiply the top and the bottom by a 2? Now watch this. If I came in, and I'll show you another way to do it, but if you notice that you're like, wait a minute, that looks really like a 2 tan theta. And by the way, look over here. What does this look a lot like? Cosine 2 theta? What does that look a lot like? Sine 2 theta, it's just missing the 2. So when I look at this, now if you didn't see that, we'll show you another way. But to me, I went, well, what if I multiplied the top and the bottom by 2 over here? And then when I do that, I can just swing this 2, since it's 2 tan theta times 2, I could just swing that 2 over to here. Does that make sense? Now, what does this give me? That is the tangent of 2 theta graph times a half. Or you could just do what with the 2? Put it underneath. Okay. And then over here, I could do the same thing. I could say, well, I really want there to be a 2 there, but I can't just multiply by 2, or I'd go to the bank, right? Get enough money for all of us, we could retire. So I would multiply the top and the bottom by 2. Now I need the 2 there, but I really don't need it here, so I'm just going to leave it. And what do I now have on the top? Sine of 2 theta, and on the bottom? You're right, 2 times the cosine of 2 theta. And what's sine of 2 theta over cosine of 2 theta? Tangent of 2 theta. But where is this 2? Still on the bottom. And now they match. Now some people see, anybody see that? Yeah, usually. Oh, you did. Nice. Did you do this?
Yeah.
Did you do this, or did you multiply both sides by 2?
No, that's what I did.
Good. That's impressive. Normally nobody gets this. No, people don't see it. Okay. Now let's just say you didn't see it, but you don't want to just stare at it. What is one of the things we do when we're like, I have no idea? Change the sines and cosines. Let's just see if we can get somewhere. All right. So I'm going to change the sines and cosines. I'm just trying something, right? So this is already sines and cosines. Let's change this. So on the top, I have a sine of theta over a cosine of theta. And on the bottom, what do I have? Here's where you got to be careful. I have 1 minus what? What is tangent squared in terms of sine and cosine? Sine squared over cosine squared, does that make sense? Because the tangent sine theta over cosine theta, but you're squaring. So this would give me sine squared over cosine squared. Okay, and I'm just going to ditto that for now. Now, what have we been saying to do whenever I have a fraction inside of a fraction and I want to get rid of that fraction inside of a fraction? Multiply the top and the bottom by what? The common denominator of all the parts. What's the common denominator of that, that, and that? Cosine squared? Okay, check this out. If I just multiply the top and the bottom by cosine squared, what happens here? One of them cancels. What happens here? I distribute it in, and then here times here, what happens? They cancel, and I'm done. Didn't even see it coming. But I just tried something. Now, I saw it coming because I've given this problem for 25 years, but the point is, try something. The first way is kind of a clever, really way to do it. And if you saw that, great, but most people don't see that. But the second way, I can do that, right? When I look at the left side and the right side, and I'm like, man, I have no idea. Let me just change it to sines and cosines and see what happens. You know, give it a shot. And then just stick to what you do. What can I do to simplify? What can I do to simplify? What else?
Number 13 from the classwork.
From the classwork? Did I skip that yesterday? Oh, yeah, I sure did. Okay, well, I got to be honest with you. I doubt I'm going to throw a log problem on there, but we'll do it. Okay, so this log problem makes you remember your log rules, and that's why it'd be a little cruel on a trig test to keep you from having success because you forgot some log thing that we hadn't reviewed in a while, but let's see if we can do it. I've got this log on the left, it's one logarithm, but on the right, I've got two logarithms. Is there any way that you know of to take a log added to a log or a log subtracting a log? Do you have a rule that allows you to do that? And what is that rule? To subtract two logs, you keep the log, but wait, there's a 2 there. Am I allowed to do that if there's a 2 out in front of the log? No, but I could swing it up. So I'm going to swing that 2 up right there. And now I have a log minus a log. And the rule is to do that, I keep the log and do what? Put one of them over the other one. And by the way, what happens when I square an absolute value? Is the absolute value needed anymore? No, because squaring it's going to guarantee what? It's positive anyway. So that gives me a sine squared theta on the bottom. And by the way, if you're thinking, why isn't it sine of theta parentheses squared? It is. We just don't write it like that. We write it like that. Okay, so here I am. Now I'm looking at this and I'm like, how on earth is this related to this? And at first glance, you might think it's not, but I'm not giving up yet. Is there anything you could possibly do? I'm looking at the right side and the left side. If I'm going to try to make the right side equal to the left side, can I have a sign in there? There's not a sign over here. So that's a hint to me that, well, maybe I could get rid of sine squared. Is sine squared equal to something cosine? 1 minus cosine squared. So I could replace that with 1 minus cosine squared. Okay, now, do you see anything that I could do just simplify this a little bit. Now, I'll give you a hint. What if I had this, 1 minus x, and I was asking, is that equal to 1 minus x over 1 minus x squared? Say I had that. How could you see, or what could you do to maybe help the problem? You see it? I could maybe factor that and see if it cancels and then it's the same. Well, what could I do here?
Squares.
That's a difference of 2 squares, right? So if I change that on the bottom to 1 minus cosine theta over 1 plus cosine theta, what cancels? That leaves me what on the top? A 1? All right, let's bring that down. Now I've got 1 over 1 plus cosine theta. Now, are these the same thing?
Yes.
Why? You got to show me.
Because if you swing the negative out, then it's a.
That's a negative 1?
Yeah.
If I swing that negative 1 up, what's it do to this? Puts it in the denominator. In the match. Now that pulled a lot of log rules out, which is probably why I won't throw something like that on there. I don't want to, again, you might know all your practice with this and then you go, oh man, I got killed on a log technicality. So, but I just want, I mean, granted, that is something, surely something like that could show up at a tournament or a state test, but that's something that you should be able to do, I guess, if you remember the log stuff, but it's probably not something I'm going to throw in there. What else? Anybody on anything on the homework or classwork?
Number 23 on page 43.
643. Number 23. Okay, and this is a great question. I have asked this question on a test, something very similar to this, dozens of times. It says cosine of x minus y, cosine of y, and then sine of x minus y, sine of y. And it says verify or prove that these are equal. Let me make sure I got it right. X minus. No, it just says simplify. So there's a minus here. So this is not a proof. So you don't have to line up equal signs. There's not even an equal sign in here. They're just asking, is this, or simplify this. Now, you know what I see people do all the time on this? First step. And it just creates awfulness. And I'm going to show you, because most people do this. So there is a way to get you out, but this is a super simple problem if you can step back a little bit. But here's what most people do initially. They go, oh, alpha minus beta identity. Sweet. I'm just going to change that to cosine x cosine y plus sine x sine y. But I got to multiply this whole thing by cosine y. And then they come over here and they go, oh, sweet. Alpha minus beta identity. And they go sine x cosine y minus cosine x sine y. Oh, but I got to multiply this whole thing by a sine of y. And they do this step and they start getting a little nervous about this point and going, oh, this is getting really gross. And then maybe they go a little further. Maybe they go, okay, well, let me distribute this in, which gives me cosine x cosine squared y plus sine x sine y cosine y. They're not feeling overly confident at this point. And then they go, all right, now I got to distribute that in and the negative in. So the sine y in here gives me sine x sine y cosine y negative. And then the sine in here gives me cosine x sine squared y negative negative positive. Are y'all with me so far? And at this point, they're going, oh, this is awful. But wait, what do you see? That cancels. So now you're starting to get maybe a little confidence back if you've made it this far. Any ideas?
You got it. Cosine X.
And if I factor out a cosine x, what's that? 1. That's a 1. And I'm done.
Isn't the third easier way to do that, right?
So much easier. So that's one way. And if you can get there, it's a lot. But here's a better way. What if I looked at this as that is like an alpha and y is like a beta. So I'm looking at the difference like it's alpha. And I'm looking at the difference because that's the same thing, right? If I look at this as an alpha and that is a beta, what do you see here? Cosine alpha, cosine beta minus sine alpha, sine beta. Does that seem familiar to you? What is that? That's a cosine of alpha plus beta identity. So if this is a cosine of alpha plus beta identity, what was your alpha again? And what's your beta? And what do you get? Done. I hope you do it this way on your test, if it shows up on your test. I haven't made your test. But I bet I asked it last year. I bet I've asked it for the last 10 years. Something similar to this.
It's
And-
it's on the first.
On the first, I've put stuff like that on there many times because it is so tempting to just, you robotically go, oh, alpha minus beta identity. And the irony is there's an alpha minus beta result sitting in front of you and you don't see it. Cosine blah, sine blah, sine blah. But if you see it like that, man, it's so easy to clean it up. What else? Anything you've seen, anything you want to talk about. If there's anything like that you've been struggling on, you're staring something at the review right now and you're going, man, this particular problem.
Number 20 on review.
20 on review number 1. Okay, so this is a proof, right? And now, kind of, I guess, well, no, plus, never mind. Okay, so when you look at this, it's really tempting to go, wait a minute, this is a sine of 90 minus theta. That must be cosine of theta. But this is sine of pi over 2 plus theta, not minus theta. So this is not an actual identity you know, is it? Is it? No. And if it's not, I do still see a what here, though? An alpha plus beta? So couldn't I actually pull out an alpha plus beta identity? And by the way, the proof to the co-function identities is using an alpha minus beta identity. I mean, I showed you with the triangle and you were like, oh yeah, the sine of one is the cosine of the other. So I showed you with that, but a proof is to pull out an alpha minus beta. And cosine of 90 minus theta ends up being sine of theta when you use that proof. But this is using that. So if this is like your alpha and that's your beta and you're adding, couldn't I say sine of the first, cosine of the second, keep that, cosine of the first, sine of the second, and then just drop this down? And then can I clean up any part of that? So the sine straight up at 90 or pi over 2 is equal to 1. So that's 1 times cosine theta. And what's the cosine straight up? That's 0. So 0 times sine. And then all that goes away, and I'm left with cosine theta equals cosine theta. And that's your proof for your alpha minus beta. It's like, if this had been a minus here, check it out. We know that identity. But putting a minus there Look, that's the proof of it. So if you ever had to prove a cofunction identity, if you knew the alpha plus beta identity, or the alpha minus beta identities, you could prove it that way as well. But this one ends up being the same for plus or for minus, which means you can memorize, and that's another identity. But again, we can only use the ones that are on our page when it comes to proving the stuff that we know. That's the only kind of, I guess it's like that's the rules. Next year, you'll learn more identities, and you'll be able to use those as well in proof. What else? Anyone? You guys want to plug away? All right. Well, I will remain up here for a moment or. Ooh, what about? Oh, we haven't gotten there yet. I'll let you mess with that. Let's walk through it. Look at 23. This is on the review, I think. This is something I have put this on a test before, something like this. So let's just pretend you are sitting there. It's test day. Somebody throws this at you. And it's prove or verify the identity. You got to do something. Right now, you're just sitting and staring at it.
You sign it 2x if x 2x. Something like that.
Now remember the rules. Am I allowed to go and divide both sides by something? No, because we don't even have two sides. Remember, the equal is an illusion. It's like a question mark. Is the left equal to the right? Question mark. We just write it like an equation. And if it is, then we can say, yes, they are equal. But right now, it's like a question mark. Okay, that's creative. And I like where you were going. You can actually get somewhere with saying let x, like you could say let alpha equal 2x. And you could actually do something with that. But let's go with Lily's, because I think that might be something many people will be able to do a little less. It'll be a little less formal. You could say, hey, 4 is 2 times 2. That I know, right? Okay, now what do you see in there? And keep in mind, guys, if I'm playing around with the right side, what has to eventually happen here? It's got to equal the left side. So this cosine and sine crap's going to have to go away at some point. I mean, the cosine stuff has got to go away at some point. So I'm looking at this. Do you see anything in there?
Yeah, it's 2 sine.
All right, see, now you're going to see it when you really know these identities, right? You see that in there, hidden in the middle. And what is that? That's the sine of double angle, right? That's the sine of 2x. So I could replace that with a sine of 2x and just drop the 2 and the cosine 2x down. Now, what do you see? I see it again. Except this time, isn't this like 2 sine theta cosine theta because those match? Now, discipline yourself. If 2 sine theta cosine theta is the sine of 2 theta, what happens when your thetas now become 2x? This will be what? The sine of what? 2 theta, but your theta is 2x, which gives you that. And now they're not. Are you seeing it? Now let's try it a different way. What if you didn't do any of that on the right and you're playing around with the left? Isn't sine of 4x the same thing as sine of 2 times 2x? Isn't it?
That's what I was trying to
That's what you were thinking? Yeah. And isn't 2x like a theta? So couldn't you think of this as sine of 2 theta? But your theta is really what? 2x. So if this is sine of 2 theta, What's sine of 2 theta equal to? 2 sine theta cosine theta? But instead of having thetas in there, what are you going to have? 2 x's. So let's write that. 2 sine theta cosine theta. Oh, look, this is starting to look familiar now. Even if you had none of this down. Look, this is starting to look familiar. Right? So I might, if I had done this, I went, okay, well, that part already matches. How can I make this and that match? And a hint might be, well, if I got a 2 there, and that's a 4, I can start to see it match a little bit. But what could you do with the sine of 2x? Turn it into what? 2 sine x cosine x. Drop that down. Drop that down. And what do I have? 4 sine x cosine 2x match. And there are a dozen other ways I could make a match at different spots or whatever. What else? Anybody else?
Wait, but how do you have it like the 4 isn't like in all 3?
Well, it's times. If it was addition, I would distribute in, but when it's time, like if I said what's 2 times 5 times 6, I could group, right? But I wouldn't distribute it and call it 10 times 12, would I? No, not unless there's a plus there. So as long as it's multiplication, you can just multiply it by any one of those 3. I just can do 2 times 2, but unless there's a plus in there, I don't distribute. Sure there's not anything else?
Can you work one of the 24 through 26, just so I like remember?
Yeah. So clearly these are on my unit circle, right? So I'm stuck. And I just said, find the exact value. We don't have a calculator. It's not on a unit circle, but you do have all these identities at your disposal. So the question is, of all these identities, I can either, you think, is there an angle on the unit circle, right? Because I need to somehow try to rewrite this as a unit circle angle. Is there one on the unit circle that I can divide to get that by 2, multiply by 2 to get it, or are there 2 of them that I could add or subtract to get it? Now, I can think of 2 things. I can either find 2 that I can add or subtract, or I can also find 1 that I can divide by 2. Because I could say like 45 plus 120, that works great. But I could also say 330 divided by 2. Now, when did I say the 330 divided by 2 would be half angle, right? When did I say half angle is a great idea? Tangent. Makes it so much easier. But alpha plus beta really makes it a lot easier with sine and cosine. So since it's a sine, I'm probably going to rewrite this as either an alpha plus beta or an alpha minus beta. What do you want to do? It's your pick. What 2 angles?
150 and 15.
150 and 15 would work if I knew what 15 was. So what's a great one to pick if it ends in a 5?
Yeah, 45.
45, so 45 and, okay, so 45 and 120. Now, what is sine of 45 plus 120? What's the identity? Sine of the first, cosine of the second. Keep it, cosine of the first, sine of the second. And now it becomes a unit circle test for you. So what are the sines and the cosines at 45? Same, so root 2 over 2, root 2 over 2. Now go to 120. Here's 120. What's the cosine at 120? You would be, hold on, cosine is the x, so you're going left a little, so negative a half. And then sine at 120, you're going up a lot, so root 3 over 2. So negative the root 2 over 4, positive the root 6 over the 4, so negative root 2 plus positive root 6 over a 4. And please don't make that root 4. You can't add roots that have different values under them. Unless you can simplify them so that they have the same, but you can't do that here. Now, if you did use an alpha plus beta identity, your answer is going to look different. I'm sorry, if you used a half angle and did sine of 330 over 2, you'll get an answer. But you're going to put yourself at more risk because remember with the square root, you got to decide if it's plus or minus. This one would be plus. And then you got to do a lot of simplifying. And then your answer still isn't completely simplified, but we accept it. So I would take it, but I don't know. What about 26? Can you think of two angles on your unit circle that you could add or subtract to get a to get a 22.5? No, I'm never going to do a decimal. So what am I going to be forced to use here? Half angle. A lot of people go, well, if I double it, I get 45. Yeah, if I double my account, I might be able to retire right now, right? But I can't just randomly do that, right? But I can half of 45 and get 22.5. That I can do. So, and it's tangent, so why not, right? Tangent of 45 over 2. Sweet. I got 3 options for tangent half angles. What's the really great one? It's the 1 minus the cosine blah over the sine of blah. And what's the blah I'm going to be using here? 45. And now I just clean it up. So the cosine and the sine of 45, we just said were. And then what do I do when I get fractions inside of fractions? So the first step would be multiply by 2. That gives me 2 minus a root 2 on the top and just a regular root 2 on the bottom. And then I'm going to rationalize. And if you look down here and you go, why don't you rationalize right now? Well, I guess I could, but the rationalizing right now would be a little tricky. I would actually be multiplying the top and the bottom by 2 over root 2, which is not the way we learned it, because the bottom fraction is already rational on its denominator. It's just not rational number. So I would probably get rid of fractions, then rationalize, and I get 2 root 2 minus 2 over 2, which is root 2 minus 1. Do you see that? And hopefully something like 25, what do you jump on right away? What does that look like? That's the double angle sine, right? So sine of 2 theta, and the theta is 15. So what's the sine of 2 times 15? 30, which you go to the unit circle, that's just a half. Now I feel a bit of a curveball on 28. Y'all know what to do on 28? Since I didn't even give you cotangent identities. I could make it a cosine over sine, but now I've got 2 to do, which is okay. You can do it that way. It's just a lot more work. But if I just flip it, I can make it a what? A 1 over tangent? So let's try that. That is a 1 over tangent of 75. So if you want to take a break right now, you could literally say, all right, let me do the tangent. Now, what would you do on a tangent of 75? Big tangent. You could do 45 and 30. And what have we said about tangent and alpha plus betas? It's miserable because there's 8, 9 steps, whatever. So much simplifying, but again, I can, but I would have to do a sine of alpha plus beta over a cosine of alpha plus beta. And you can do it, just a lot more work. Watch how easy this is if I use a half angle. What's a half angle tangent? It would be tangent of what? What can I half and get 75? 150? Okay, I'm leaving it under 1, right? That's how I rewrote it. Let's just keep doing it. So what do I get here? If I'm using a half angle, just leave it under 1 for now. What's the tangent of the half angle identity? You got 3 of them. Now I'm going to write that because I've been telling you it's my favorite, but not the cotangent. But I'm going to write it. So here the rule is, if you use that one, you would have 1 minus cosine 150 over sine of 150. Are you with me? But what is 1 divided by that? It's reciprocal. Now there's nothing wrong with this. You can simplify this. It'll take you a few steps. You're fine. But if I know then I'm gonna end up flipping it because it's a cotangent. Now, which one's my favorite? Now, the sine of 150 over the 1 plus cosine of 150 is my favorite, because when I flip it, what's it leave me on the bottom? Just a monomial. That I like. Now, it's only going to save me a couple steps, so it's not a big deal. If you just, the one I start and I say I normally like the 1 minus cosine over the sine, you stick to that. It's not like it's a big deal. You're just saving yourself a little bit simpler process. Because look, what's the cosine at 150? Left a lot, so I would have 1 plus a negative root 3 over 2. What's the sine at 150? Up a little, 1/2. How do you simplify this? Multiply the top and the bottom by a 2. When I multiply the top by a 2, look, 2 minus root 3, bottom by a 2 is 1, done. If I didn't use that formula and flip the other one, it's okay, but I'm going to have to rationalize with a conjugate. It makes it a little harder, a little more work for me. Now, I got to be honest with you, I don't do all this. I don't write all this junk. I go, wait a minute, if I want to do a half angle cotangent, what I really want to do is this, right? If I want to do half angle cotangent, I just go, well, let me just flip a tangent identity. So I take the tangent identity that looks like that, and I just flip it. And I go straight to this. Literally, that's all I would do. I wouldn't write that, or that, or that. I'm just going to go, oh, half angle cotangent, flip one of my tangent identities. Just flip it, because that's all cotangent is. What if I said, hey, what's cosecant of, pick a nice one. What's cosecant of 15? What would you normally do with a 15 if it's not tangent? 45 minus 30? Now, if I don't have a cosecant identity, what is the cosecant? What's closest to that? Cosecant's 1 over sine. So couldn't I just take the sine one, the sine of alpha plus minus beta, and put it on the bottom? I'm just going to take it and flip it. That's all I'm doing. I'm going to have to rationalize this when I'm done, but that's all I'm doing. Just cleaning it up. I've seen that. I don't do a ton of that. This one I do a little bit of because it's kind of nice and neat. And I might ask you, like on a quiz, my last quiz, I always like to throw a curveball or two at you. So on my last quiz, I might say, hey, what's cosecant of theta? You're like, what? No, I'm sorry. I might say, what is, maybe I do this. What is sine theta, cosine theta, sine beta under a 1? And my hope is you go, well, I don't know. That looks like a sine of alpha minus beta. What's a 1 minus or 1 over a sine of alpha minus beta? It must be a what? Cosecant of an alpha minus beta. So little things like that, hopefully you can clean up. Ready for a 3-day weekend?
Yes, yes.
I think we've all learned it. All right, guys, please study up those identities. Humor me. Set yourself an alarm on your phone so you don't walk in here on Monday and go, holy crap, I forgot about that last identities quiz. Make it count, especially those who've struggled a little bit.